Now, one of the other terms you're going to hear a lot is asteroid. And an asteroid is nothing but a minor planet. If something is really big, it gets to be a planet. If it is not so big, it gets to be a asteroid. And if it is even smaller still, it's going to be a meteorite. And so we're going to talk about those. There are only 6 asteroids that are known that are more than 375 miles across. 375 miles is, yeah, that's kind of like the length of Wisconsin from one tip to the other. That's big. That's a big, big, big thing. So some of these are quite huge. There are hundreds of them that are known to be over 160 miles across, and there's over 100,000 of them that are over 16 miles across. Why 16 miles? Well, it's 10 kilometers, and I translated into miles for us Americans. Anything smaller than that is basically called a meteor or meteorite. All the asteroids together that we know of in the solar system has less mass than the moon. So they're not everywhere. They're kind of rare. They're small, but we worry about them because of the fact that if one of these would hit the Earth, we would be in deep trouble. These are a couple pictures of asteroids. They are not large enough to pull themselves into a round shape. That was part of the definition of a planet, enough mass to pull itself into a round shape. Asteroids are just too small to do that. This asteroid is kind of nifty because you can see on the asteroid, you can actually see impact craters, and I think that's quite beautiful. The composition of the asteroids are going to vary depending upon what part of the solar system was actually created in. And if we can find asteroids, if we can send missions to them, we can actually take samples of what the solar system was like right at its beginning at different locations, because most of the asteroids are going to be exactly in the same position they started in. So if here's the sun and you have the asteroid belt between Mars and Jupiter over here, those asteroids that are here are going to be an indicator of what kind of rock and debris was here. If you find asteroids in different areas, those are going to give you indicators of the rock and debris in that part of the solar system. Here are a collection of some of them. I'm not going to ask you to name any of these asteroids. They have lots of little nifty names. I love the fact that one of them is named Anne Frank in recognition of that young lady. So they're just fun and crazy, and they're people. This is what they do for a living, is mess with the asteroids. The asteroid belt is an area, as I mentioned, that is going to be between the orbit of Mars and the orbit of Jupiter. A lot of people believe, a lot of scientists believe, that there was enough mass here for a small planet to be produced. And because Jupiter is such a big beast and gravitationally kept tugging on this poor baby planet as it was being produced, that it never actually had enough stick-to-itiveness because of Jupiter's tugging to become a planet. Only about 4% of a planet's mass exists in the asteroid belt. Most of the rest of the mass, due to the gravitational tugs of Jupiter and Mars, has been flung outward to different parts of the solar system. So what that means is the asteroid belt is not very dense. Now, if you look at Han Solo and the Millennium Falcon flying through the asteroid belt, it kind of looks like that. Hollywood has given us the impression that it is terrible and there's no way you're going to get a spacecraft through that. Well, honestly, every time that we send a probe to the outer solar system, they actually worry a little bit about hitting something in the asteroid belt, but it's not a big deal because Star Wars lied just a little. We're currently sending missions to asteroids and comets. We want to find information about what these things are made of. In 2010, the Japanese sent a probe, and it was called Hayabusa. Hayabusa, and forgive me if you speak Japanese because I do not, this actually landed on an asteroid. We could take core samples. We can get an idea of exactly what it was made of. The European Space Agency in 2014 landed the Rosetta on the Churyumov asteroid. And why are we spending lots of money and bother trying to send probes to asteroids and comets? Well, primarily we're trying to save life on Earth. It is going to be only a matter of time before some asteroid, some comet, is large enough to actually impact the Earth and potentially be an extinction event. Those extinction events are something for us to worry about. And so right now, scientists are trying to figure out, how do we nudge one of these? If it's far enough away, yes, one of the things that has been hypothesized is to put a little nuclear bomb on it, and that nuclear bomb would explode it and send it off in the other direction. The challenge is, like the Shoemaker-Levy 9 that hit Jupiter, if you break this thing into smithereens and each smithereen hits the Earth is still toast. Some of the other things that is being looked at is to put a spacecraft next to an asteroid, and due to plain old ordinary force of gravity, if the mutual gravitational tug of a spacecraft, because a lot of these probes are about the size of a school bus, this could potentially move or nudge the orbit just enough to keep the asteroid from hitting the Earth. This is not violent, is not going to create a lot of debris that might come back and hurt the Earth later. The challenge with this is it has to be done early. And that's why a lot of astronomers are looking at asteroids and things to see if we can protect the Earth by mapping where these are and then nudging them if need be, if they're getting too close to our planet. Okay, that is going to do us for asteroids, and we're going to come back next time and we're going to talk about meteors.